Today we will talk about segments, rays, and distance. This is section 1-3 in your textbook. Our essential question for this lesson will be, what are the definitions of segment and ray, and what is a postulate? As you recall from our last lesson, we talked about a line extending infinitely far in both directions. Okay, I've drawn a line here on the screen. We could refer to it as line AC. So what do we mean by line segment? Basically, a line segment is a portion of a line. We could refer to segment AC. This consists of a line that starts at A, ends at C, and includes all the points between A and C. So if we're talking about segment AC, we would represent it by AC with a line over it. But notice we have no arrowheads at either end because this is a line segment. Starts at A, ends at C, okay? So that is segment AC. Now a ray has attributes of both a segment and a line. It has a specific starting point, but it has no ending point. Now what I've drawn here is a ray that starts at point M and heads in the direction of N and then continues on infinitely far past N. So ray MN would be represented by MN with a line over it, but notice it's only got an arrowhead over the N. The first letter is always the starting point of the ray, the second letter is the direction it's going in, and the arrow above goes in the direction from the starting point to the direction it's going in. So this is how we would represent ray MN. Now I've drawn a line which we might refer to as line RT. But notice I've got another point on it, S. Now we could say on this line that we have two rays. One of the rays is ST, starts at S and goes in the direction of T. And the other ray is SR, which starts at S and goes in the direction of R. These are considered to be opposite rays. They start at the same spot, but they head off in opposite directions. So ST and SR are considered opposite rays. Now let's consider another line. Let's discuss line JL. Let's say we want to determine the length JL. Well, if you think of this line as being a number line, and J having a certain coordinate, and L having a certain coordinate, the length of JL would simply be the distance between J and L. So this would just be designated by JL, okay? Notice there's no line above the J and the L. There's no arrows or anything like that. So if you just see the two letters, where we're going to refer to it as the length or the distance between J and L. Now one other thing to consider is the fact that the length is always going to be positive. There's no such thing as a negative length, okay? So even though we're going to equate this to potentially a number line, remember that the length is always a positive number. So now we come to the term postulate. What exactly is a postulate? A postulate is a statement that is accepted as true without proof. In some books it is referred to as an axiom. Now in this book, the postulates are going to be numbered, and I do not require that you remember the postulates by number. I do want, however, you to remember the postulates in your own words, okay? To remember how do you describe it, maybe give it a title, but be able to do this in your own words so that anyone would know which postulate you are referring to. We now have our first postulate, postulate 1. It's known as the ruler postulate. It states, 1. The points on a line can be paired with the real numbers in such a way that any 2 points can have coordinates 0 and 1. 2. Once a coordinate system has been chosen in this way, the distance between any 2 points equals the absolute value of the difference of their coordinates. This is a very wordy, long postulate, which basically means you can take a ruler and measure the distance between 2 points on a line. That's basically what it says, the ruler postulate. And this leads us to postulate 2, the segment addition postulate, which simply states if B is between A and C, then AB plus BC equals AC. And we can see this fairly clearly on the example I've shown here, that if B is between A and C, then the distance AB plus the distance BC is equal to the distance AC. Now we have a few more definitions that we have to understand before we can proceed too far into geometry, and the first of these is congruent. So if we are using it in terms of line segments, we would say that congruent segments are segments that have equal lengths. So if you've got 2 segments that have equal lengths, they are said to be congruent. The next of these terms is midpoint of a segment. The midpoint of a segment is the point that divides the segment into 2 congruent segments, or 2 equal segments. And lastly, we have bisector of a segment. A bisector of a segment is a line, segment, ray, or plane that intersects the segment at its midpoint. Now that concludes today's lesson. Now I would like you to look at the following examples and fill in the blank with always, sometimes, or never, and post your answers in the drop box.